Hello and welcome. In this Max tutorial, we will create floating windows that sample different regions of a screen space texture. So the idea of this tutorial is that we will create a texture that spans across the entire screen in normalized space. We will then create different floating windows, and each of the windows will sample a specific region of this global texture we created. Then the window position and the window size will determine an offset and a scale for the sampling coordinates of that window. So we will generate multiple independent viewports over the same underlying texture, so to say. So this tutorial consists of 3 parts. In the first one, we will create a single window that will then use its own position and size to sample specific regions of this texture that is spanning the whole screen. Then in the second part, we will create multiple windows using polytilde. And in the third part, we will look into how to animate those different windows. I will start with just an input video. And yeah, I think that's it. We can now proceed with the first part, creating a single window. In order to create a window, I will create a jit world object. So this is the rendering context for a single window, and it also creates the window. So here we can give it an initial window size. Let's do something like 250 by 250. Then the dimension of the texture will be full HD. Then, very important, floating 1. So the window will always be floating on top. I usually don't do this because I think it's in some cases it's kind of annoying to have this thing floating on top all the time, but here it's kind of essential. Yeah, I think that's it. We should also give it an initial name, but we can just put this here. Let's call this one window. Okay, here we have our window. Then we need a toggle to start this. Yeah, so we have the window and the jit world object. What I now need is the window position and the size of the window. In order to get this, I can use the message get size and also, get size and also the message get window position. And this should theoretically come out here. Okay, we have window position and first the window size. I want to bang this on every frame, so I will use a jit bang object. Then here I want to, what do I want? I want to get them individually, so I can use a route object. So first I want the window position. And then I want the size. So here I'm getting the position, here I'm getting the size. If I change anything, you can see these numbers are changing. But now they're in like screen space. So these are the actual, so this is the window position and the window size in actual like pixel position and pixel size. So I want to normalize this. So I want to get a number between 0 and 1. In order to normalize this, we can use the object screen size. So this will give me the size of the whole screen. And if I'm dividing what's coming out here by the screen size, then I should get a number between 0 and 1. So in order to do this, I will say trigger bang list. So I want to bang the screen size to get an output. Then, okay, let's look inside here. Okay. So I first need to unpack this. So I can use the unpack object because I only need the X size and the Y size. Yeah, I think in order for it to be tidy, I will pack this up again into a new list. Okay, so now I'm getting the output here and I'm getting this output here. Then I need to divide this window position by the screen size. So in order to divide items of a list, we can use this object, v expression. So here we can say, wait, what's the syntax again? I always forget. I think it's $float2. So I want to divide this number by $float1. Okay, seems to be right. Let's see. Didn't get any errors. Okay, so here we're very close to 0 and here we're very close to 1. Okay, this seems to be right. Okay, then I need essentially the same thing for the size. So I can just copy this thing because the size, I also want to get the size in terms of the screen size. So again, normalized between 0 and 1. So let's see what's coming out of here. Okay. Okay, this also seems to be right. So what I want to do now is I want to sample this texture and then take the window position and the window size into account. So in order to do this, I will first create a texture and just make the size explicit. Then I can put this here. Let's also create a P window so we can see what's coming out of here. Okay, now we can see our flowers. And now I want to... So essentially what we're doing is if we're shifting the window to the right, this whole texture has to shift to the left in order to show only this portion that we're interested in. And if we're making this smaller, this has to get larger in order to just show us what we need to see here. Okay, in order to do this, I will use jit.gl.pix codebox. Put this in here. And then the output that we're getting here gets plugged in here because then we can see it in the window. And now you can see that we're getting the whole texture, but it's weirdly distorting and it also doesn't change the position. In order to change this, I will create two parameters. The first one, let's call this one pos for position. So this is a vector consisting of two values. And then the second one, we can call this one just scale, also consisting of two values for the x and the y axes. Then we can create UV coordinates. So these are so we need the normalized coordinates, multiply them by the scale, and then add the position. And then we can say output 1 equals sampling input 1 with our UV coordinates. Okay. I made a mistake somewhere. Patch cord outlet out of range. Oh, because of this typo here. Okay, now, as you can see, this is not working because we also have to plug those in here. And yeah, I will use a prepend object for our position and for our scale. So we're sending the right message. So position and scale. Oh no, that's not what I wanted. Aligning those, okay. So now you can see that we're scrolling through the whole texture and it's essentially doing what we want. So changing the window size also changes how much of the texture is visible. And then we can move this whole thing around and only see this part of the texture that we're interested in relation to the whole screen size. Okay, I think this concludes part 1. So we have one window and now I want to have multiple windows. In order to do this, I will use a poly object, poly tilde. And I will put this whole thing into the poly tilde object. So what I will do is, first of all, let's save this, close it. Then we can call this one window manager. Then I will duplicate it and call this one floating windows. So in our window manager, I will get, first of all, I will get rid of this texture. So Command X. Then in the floating window, I will get rid of the JIT world. No, that's not what I wanted. All I want to have here is the texture for now. And I want to send this texture to the poly object. So in order to do this, I can just create a send object, call this one texture send, because every instance of the poly object will get the same texture. So we can put this here. And then again, opening the window manager. Then here we can create a receive for the texture send. Okay, I forgot. Is this even? Okay, this is called texture send. And here I'm getting texture send as an input. Then here's the window. Then what I also want is a load bank object in order to turn on this, this JIT world. Or just load, no, sorry. Load mass 1, sending a 1 into here, into this one, so this turns on. The problem now is that within the poly tilde object, all of these JIT world objects will have the same name and we can't have that. So I will erase the name and just create it when the object is created. So we can use this poly object, which will give us the instance of this patcher within the poly system. So for the first patcher, we'll get a 1, for the second we get a 2, and so on. So if we say load bang, then we'll get the instance, and the instance will then name this one. So we can use the object sprintf. We can say name, something like window. And then what was the syntax here again? I think this should work. I will take a quick peek. So pretending this is the first one, this will send name window 1. Okay, this should work. So I plug this in here. Okay, so if we load this thing, we'll get a unique name. So there will be no conflicts. And we'll also turn on this jit.world object. Okay, so let's save this one. Close it up. Then now we can create the poly object. Get the exact name, and then the number of instances. So for example, 5. So now we can see 5 windows here. And hopefully if I'm sending the texture, yeah, it's working. And then, yeah, you can see that we'll always get the texture in the background that's spanning the whole screen in relation to the window position, which is a pretty nice effect. Okay, so I think this concludes part 2. We can now go into part 3, the animation. So how could we animate this? I mean, it's also a lot of fun to just do this, but we could also animate the windows and have them floating around. In order to do this, I will use a jit.bfg object. So I will basically use a noise function and then use the cells of the matrix that this BFG object creates to control the positions we have here. So in order to do this, let's start by creating a jit.bfg. We need 2 planes because we have an X position and a Y position on the screen. Then float 32. Then let's say 100 for 100 positions. So this would be then the maximum number of windows we could use. And then 2 and 2, which is the minimum value that the other dimensions accept. Then as a basis, we can just use noise simplex. And yeah, I'm using a very high scale parameter because experimenting with this, I found out that the higher the scale parameter is, the more noisy it gets. Because if you have a low parameter here, they are pretty much all doing the same motion. So I will use at scale 50 for now, but you can just experiment and use whatever fits best for you. Okay, then let's create a window to have a look inside. We also need to change the offset frame by frame. So in order to do this, we can send the message offset 00 $1, and we also have to bang it. Then we can use a jit time object, but I think this will be too fast. So maybe let's say at speed 0.2 or something like that. Okay, what we have now is Yeah, almost what we want. What first needs to change is, so now the values are not between 0 and 1. So in order to get them in a range between 0 and 1, I will use the object should normalize. And I also need to feed this into a matrix that we can then access from our window manager. In order to do this, we can create a matrix, call this one pos for position. This also has 2 planes, also float 32. And yeah, we don't need the other dimensions. We just need it to be one dimensional. So 100 times 1. And then we can also say depth 0. So this doesn't change. Okay. So if I then create a matrix within this polypatcher, also give it the same name, then this will refer to the same data, which is pretty handy. Okay, then maybe let's first look into how we could access these positions, because essentially what we need now is the window position, but not normalized. So now this ranges from 0 to 1 in both directions, but we don't want it normalized. We want it like as actual pixel positions. So in order to get those, we have to multiply this by the size of our screen. So what we can first do is, yeah, this is kind of annoying. That's why I don't like to have the floating window. So we'll set this just to 1 and put it somewhere where it's not in the way. Okay, yeah, how can we access this? I will create it here in the parent patcher and then put it inside the window manager poly. Yeah, so jit matrix pos. So this is essentially the same thing we have here if we're using a jit bang object. To bang it every frame, we get this. Then in order to get from a matrix to individual messages, we can use a jit.spill object. And I want to access different planes because one plane is for the x-axis and one is for the y-axis. So I can specify this by saying at plane 0 for x and at plane 1 for y. Then in order to keep it clean, I will use a trigger list object. Then, yeah, we can already see that we're getting 100 values for the x position and also 100 values for the y position. But in here inside of the poly object, I only want the position that is corresponding to the actual instance. So in order to get this, we can use zl dot. Oh no, didn't mean to do that. So we can use this one and then specify which index we want to get here. So the second inlet just tells us which index of this list we want as an output. And in order to get the corresponding index as an output, we can use this poly object again. So I can just copy this and put it here, then trigger integer. Put this up here, plug this in here. And again, if this is inside of our poly patcher, we will get the corresponding index for this instance of the patcher. Okay, Yeah, what next? As I said before, these values are in the range of 0 to 1, but we want it in a range of 0 to the screen size. So we again have to use the screen size object. Also with a load bang. So here we're getting the screen size. Then again, we have to unpack it because the values we're interested in are here. So unpack 0, 0, 0, 0. Then we can pack this again, 0, 0. So now we should be getting a list with the X and Y screen size. Okay, perfect. Now we have to multiply this output by these numbers so we get it in the right range. So we can again use the v expression object. What was the syntax again? $, float1, and then we just have to multiply. So this in the range of 0 to 1 by the screen size for the x-axis and screen size for the y-axis. So $float2. And also we have to pack those two together in order to get a list. Again, the first value is the x-axis and the second value is the y-axis. Okay, and if I didn't make any mistakes, banging this again. Yeah, so now we're getting coordinates in the actual screen space. Yeah, I think I can now take this whole thing and put it in here. Running out of space as always. Putting this up here. Then also, this doesn't need to take up this much space. Okay. I think my tutorials would be just like 5 minutes long if I didn't waste that much time tidying up my pictures. Okay. So now we need to send this window position to our jit world object. So in order to do this, we can use prepend window position. Wait, window position. This also needs a load bang. And now you can see that it's already moving. What I also want to do is, because when I first came up with this, yeah, you see it can be quite annoying. So maybe let's use a gate object here. That can be controlled from the parent patcher. So maybe use a receive here, call this anim for animate. And if this is a 1, the message that's coming out of here, we're animating the whole thing. And if it's a 0, we're not animating the thing. Did I forget anything? Let's see. I will just save this, close this. Then I will use a send anim and then this toggle. Yeah, this works. And what also might be a good idea, because if you have something like this, then you can't click it. So I will use the key object and then maybe use the A key, which is 97, in order to activate or deactivate it. So I can even deactivate it if there's a window right in front of it. Select 90. Oh, what am I doing? Select 97. What just happened? Okay, again, select 97 now. And now if I'm pressing A, yeah, this is moving. Okay, putting the whole thing together, starting the video. Maybe let's just say 10 windows, then pressing A, and now we have 10 animated windows. And if I want to stop this, I can press A again. I can rearrange them. Yeah. What you could also do is, for example, also use this BFG to change the size of each window. This could also be done, or it could also be animated. You could also use some more clever algorithms in order to animate those windows. But yeah, I guess that's up to you. So this is essentially what I wanted to show you in this video. Yeah, I hope you found this useful. Thanks for watching.